Hello students, good morning to all of you. Students, our today's topic is lens formula. Okay, in the previous class, we will discuss about the image formation by lens and their characteristics. So, we will start with lens formula. Let's say we have a convex lens. This is principal axis and this is focus point and this is curvature. Okay, left side of the lens or beyond the lens there is an object of height h is placed. Therefore, the ray which is traveling parallel to the principal axis, it passes through from focus, and a ray which is passing from center of curvature after refraction is moving in the same path. Okay, therefore this is location of image of A if rays are traveling from A, then at where the two refracted rays intersect is called image of that point from where the rays are coming. When we draw a perpendicular on principal axis, we get the location of B dash. Now AB is object, therefore A dash B dash is image of object A. Okay, now some things which we have here. By this point, let's say this point is M. Okay, by dropping a perpendicular on the principal axis which intersect at O. Okay, therefore we have two triangles. One is ANO and other one is this O or A dash B dash O, and next triangle NOF and A dash B dash F. Okay, we have two triangles. Now this is the object and distance from lens to object is U. Distance of focal length from lens to focal point is F, and distance from lens to the image is B. Okay, now consider a focal length or consider a convex lens of focal length F. An object is placed in front of lens where from the object two rays are moving towards lens and after reflection incident at A dash. Therefore, A dash B dash is image of object A. Okay, now from figure, this is triangle 1, this is triangle 2. Okay, in triangle ABO and in triangle A dash B dash O. Clear? A dash B dash O. Now in this triangle, this is triangle 1. In triangle 1, this is 90 and here also is 90. Now these two angles are vertically opposite angles. Therefore, angle B equal to angle B dash is equal to 90, and let's say angle 1 and angle 2. Angle 1 equal to angle 2 because vertically opposite angles. Hence we say here that triangle ABO is similar to triangle A dash B dash O. Clear or not? Therefore, first here we have AB is equal to OM. Clear? OM. Okay? Yes. So we can use this AB upon A dash B dash equal to, by using distances OB and OB dash. OB and OB dash. Okay? Now this is equation first, and in triangle NOF and in triangle A dash B dash F, A dash B dash F. Okay, angle O equal to angle B dash because in these two triangles, okay, is equal to each 90, and similarly this angle and this angle is vertical opposite. That this is angle 3rd and this is angle 4. So angle 3rd equal to angle 4 is equal to vertically opposite angles. Then from here, triangle NOF is similar to triangle A dash B dash F. Okay, therefore NO upon A dash B dash is equal to OF upon FB dash. Okay, OF upon FB dash. Clear? Therefore okay, we can also write here AB upon A dash B dash is OF upon FB dash because we have AB is equal to NO from here. Here now this is equation second. By equating equation first and second, by equating equation first and second, we get OB upon OB dash is equal to OF upon FB dash. It is clear or not? Now we need to calculate all these values. So see here, OB is distance of image which is equal to minus u because the object is placed in front of me. Next, OF is focal length which is in the other side of the lens is positive. We are using here all the values of distances by using convenience sign of Cartesian axis. Okay, second, next O dash B dash. O B dash. Where is O B dash? O B dash. O B dash is distance of image, and next we have F B dash. F B dash. This value we calculate by OB dash minus OF, which we get from here V minus F. Okay, F B dash. By putting all these values in this equation, we get U upon V is equal to F upon V minus F. Here, now multiply this, we get from here U V minus F is equal to Vf. Here, by multiplying inside, we get UV minus UF is equal to Vf. Okay, let's say this is equation.
So minus
Where?
minus OBT
Yes, this is minus. So this we have minus and this is plus. Clear? Now, by dividing equation third, by UVF. What we get from here? Minus UV upon UVF plus UF upon UFV and equal to VF upon UVF. Now, these we have in denominator. By denominator, numerator cut. By this bracket, numerator also cut, and by this bracket, it will be cut. What we get from here? Minus 1 upon F plus 1 upon V equal to 1 upon U. Okay? Now, finally we get 1 upon F is equal to 1 upon V minus 1 upon V. This is required answer. Okay? What else? From the last 4 or 5 years, in the consecutive years, this formula are in the 12th class in your board exams. So it is little bit important. Okay? Now we are understood about the magnifying power of this convex lens. Now, next we have the linear magnification or magnifying power of lens. Before we understood about the power, in the figure, as you understood that the height of image is HO and the height of object is SO and height of image is HI. I for image and O for object. So, by using the nature of the image, it is most important about knowing the characteristic of the lens. Okay, what we have? Nature is real or inverted. Okay, second, orientation. Orientation is real and virtual. Orientation, inverted or directed. Okay, now here for inverted and real, inverted and real image, just understood about these things. Inverted image is vertically down, so it is taken as negative. Second, the inverted image by lens is from other side of the lens. Okay, so U is negative, HO is positive. Okay, V is positive and HI is negative. Clear? And second, for virtual and elected image. As we discussed the last case in the image formation, the erected image is formed in the same side of the image. That is, U is negative, V is also negative, and HO is positive, and similarly HI is also positive. Okay, these are some characteristics of the image formed by the convex lens. One thing is also, here we can write that virtual image formed by convex lens, HI is greater than HO. This is most important. ठीक है, but for concave HI is smaller than HO. Just understood. Okay, now linear magnification produced by a lens. It is basically the ability of lens to conserve, okay, or to form the image. So it is denoted by small m, and right, linear magnification produced by lens is defined in the ratio size of image, that is HI, to size of object. Okay, done. And it is also defined as the distance of image, that is V, to distance of object, that is U from the lens. Clear? Now this M we are taking here for the real case. Real for for real image. Okay, this m is equal to, as in the figure, height of image is inwardly downward, so it is minus h height. Okay, and height of object is erected, so it is h4. Second, we have distance of image, which is positive because the image from real image is in the other side, and distance of object is negative. From both the formula, the magnification is negative for real image. It is clear or not? Okay, now comparing these two formulas, we get from here this minus multiply here, and we get the result is positive. So in the question rarely asked that the height of image calculate. So this is equal to v upon u into height of object. This is for real case. Clear? Okay. One thing also understood from here. Minus 3 or plus 3. The type of magnification of lens is minus 3 or plus 3. Not indicates the size of image. Okay? That is, as you know, the minus 3 is very smaller than 0, or 3 times smaller than 3 digit smaller than 0. But here this only define minus define for 3 times size of real image, and this define 3 times size of virtual image. It is clear? Now, for virtual image, whatever the kind of lens, this m is in the virtual case, as we write here, the height of image and object both positive. So by this hi upon ho we have positive, and equal to distance of images both are negative, that is minus v upon minus u, that we get v upon u. Clear? Therefore the magnification is positive for virtual image. It is clear or not? Now again by comparing this, we get the result. Height of image is equal to v upon u into h. This is all about the magnification produced by the lenses. Okay? Secondly, magnification for two cases. Magnification m for virtual case. For virtual case, m is equal to plus 3, either plus 2, either 3 by 2, either 5 by 3. Okay, each indicate m is greater than 1. Okay, which means image formed by a convex lens. Convex lens. It is clear or not? So, if magnification is smaller than 1, what is the meaning of it? That image formed by a concave. Image formed by concaves. Clear or not? If magnification is greater than 1, it means that the image formed by convex lens, and if the magnification is smaller than 1, it means that image formed by a concave. It is clear? Here, if m is negative, what idea you get from here? That m is smaller than 1 or that m is not smaller than 1? If the value of m is given with then -3, it implies here that m is smaller one or not smaller one.
Not.
Yes, that's it. Smaller than 1. One of you asked that not. Who? Why?
Negative sign indicates inverted.
Yes, because negative sign here not indicates the size of image. It only indicates the nature of image. That image is real or virtual. This is most important thing. Here, when we are go through with this, then we use here only mod of 3, and the value of mod of 3 is equal to 3 only. Okay, done. Next we are discussing about the combination of it. Okay, done.